Hey everybody, this is Larry. This is day 5 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, 138, copy list with random pointer. Let's check real quick. Check real quick because on the upper left, there's an unbox surprise. You click on it, you get 10 lead coins. Guess it adds up over time, I don't know. Anyway, I think we've done this problem not that long ago. Also, first of all, hope everyone's having a great Labor Day or had a great Labor Day. And I did a very long hike without sleeping enough, so I'm just like kind of drained, to be honest. But I did take a quick nap on the bus, so maybe that's good enough. We'll see how that goes. Okay, so linked list is of length n. I feel like we did this problem recently. Like maybe not super recently, but still like recent enough that probably my previous video is not that bad. So if you don't like this video, you can definitely look up that one. Yeah, I mean the way that I like to solve this is kind of with just like a getter. Yeah, with a getter, and then with that getter, you can almost like a memorized version of the getter that doesn't have the random or without the next order random, and you could hash it on actually the node that they give you. So let's do that. Maybe the one I'm thinking of is a tree or something. I don't know. Yeah. Oops. Cannot type today. So while current is not none, current is 0, current.next. So this is just writing the iterator, which there's a cleaner way to write this. I feel like, I think maybe you have to write like some kind of hash next for the node class or something. I don't know that much Python, so who knows. But in any case, so then now we maybe one, new current is equal to none. Actually, we don't really new current. What we want is new head, right? Yeah. So this is the thing that we're gonna return is equal to. Let me make it brighter. I don't know why it's so dim on my laptop. Let's just say get node of current or just the head, right? And we could just write a get node class here that would kind of take care of, basically what we want to do is do two things, right? One is kind of construct a memory for we want to construct a memory a copy of the memory. Oh, sorry, what am I saying? Sorry, friends. You want to construct a memory. You want to. Man, I'm finding it tough to find the words. Basically, you're trying to allocate the memory for a copy for each of the existing nodes, and then the second is to actually have pointers to them, right? And actually like set the pointers up to a good way. And this is the way that I feel like I've been doing it for a little bit. So yeah. So basically, get node copy gets a copy of the node. And basically, we can say return a new node of, or maybe like copy is equal to new node with only the x or the value mattering. So node.value, and then we could avoid the other pointers for now, and then we return copy, right? And how do we ensure that subsequent what am I doing? A subsequent calls to node of the same node. How do we be sure that we return the same pointer? Well, we just do a memorization, or just like a lookup, really, right? So here is if node is in lookup, then we return lookup of node. Otherwise, and lookup of node is equal to copy. And I've gotten a question about why this works in the past, and the reason is because what happens is if by default node, the ID of node is the hash thing. So for an object, which means that the memory address, not quite what ID is, but it's a good approximation if you know what that means, is that the memory address of the object gets hashed. And because actually in this case, this is actually what we want, because we because the memory of the original node doesn't change, right? So yeah, so basically that's basically the idea. And then yeah, so now we can just write write new head. Yeah. And then maybe current is equal to new head, right? Not I reused this, but current or new current maybe. Oops. And then new current dot next is equal to get node copy of current dot next. Maybe I'll write this a little bit differently. I feel like the way that I wrote this is a little bit awkward, that's why. Because the way that I like it is actually with a sentinel, and I skipped using a sentinel this one because I thought it would be, I don't know, I was just lazy to be frank. But it seems clear to me that that actually made it a little bit, yeah, unfortunate. So here, let's, instead of doing this, new head is equal to some node, right? And new current is equal to new head. And then here, so we want actually new current is equal to, so this makes it a little bit harder to, or a little bit confusing, but let's just say sentinel is equal to node, and where sentinel to the next, maybe just -1, and then the next will point to head, and then current is equal to sentinel, right? And then now we can do stuff from all the next. So yeah, new current dot next is equal to this, new current dot, I think random, but then it should be none in the first case. So yeah, maybe we just write something like if node is none, we return none, just to keep it consistent. Yeah, random is equal to that node copy current dot random, and that's pretty much all we have to do. Oh, and well, new current is equal to new current dot next. And then we just new head dot next. I think I have to do a -1 here because we need a Y user requirement maybe. Yeah, so that looks good. Let's give it a quick submit. And we're Gucci. Oh, only 3 times. It feels a bit more. Yeah, this is linear time, linear space. Everything is over 1, right? Except for the while loop, which obviously we have to do because we have to look at every copy once. Yeah, the core idea is to separate the allocation of memory and the getting or the setting the pointers. Yeah, and this thing only allocates memory the first time you see a node, no matter whether it's from the next or the random. So so then the next time you get it, you just look, it goes back to the same memory allocation. So yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see you the rest of the week. Bye bye.